Ew. Oh my gosh. Retweet. Hmm? Oh my gosh.
Dude, what are we gonna tell her? I honestly don't even know, but I'm gonna wing it. Oh god. They're here. Coming! Hi! Hey guys, did you get the tickets? About that.
What do you mean? Have a seat. So what's the problem?
We didn't get the tickets.
What? What do you mean?
So we tried to find the best time to go get the tickets, but
Jeez. That's a really long line. Maybe we can come back later and it'll be shorter.
What are you guys looking at?
I think it's best if we explain this with some calculus. I actually have the calculus right here. So prom tickets went on sale at noon and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for 0 is less than or equal to t, which is less than or equal to 9. The values of L of t at various times t are shown in the table above.
I'm still confused. Can you explain it better?
Yeah, let's go over here.
Okay, so what's the estimate rate of people waiting in line around 5:30?
Use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m. T equals 5.5. Well, to figure out rate, we can look at slope. And since it was 5:30 p.m., we can look at hours 7 and 4. To calculate this, we can use the formula y2 minus y1 over x2 minus x1 equals m, or slope.
So what does the x and the y represent?
Well, hours would be represented by x, and the number of people in line would be represented by y. At 7 hours, there were 150 people in line, and at 4 hours, there were 126 people. And don't forget to include your 7 minus 4 accordingly. Using my calculator, I can do 150 minus 126, which gives me 24. Divide that by 7 minus 4, which is 3. and in total, I get 8. In conclusion, the rate of people changing in line was 8 people per hour.
Oh, I see it now. So how do we estimate the average number of people waiting in line during the first 4 hours that the tickets were on sale?
Well, I can help you out with that.
Use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that tickets were on sale.
So you would take the numbers from these 3 intervals, and then you would add the number of people at time 0 plus the number of people at time 1, and then divide it all by 2. And then you would divide it by the time that has passed, which is 1 minus 0. And then you would add the amount of people at time 1 plus the amount of people at time 3 and divide it by 2. And then you would multiply it by the amount of time that has passed, which is 3 minus 1. And then you would add the next interval, which is the amount of people at 3 plus the amount of people at 4. Divide it all by 2. And then again, multiply it by the amount of time that has passed. And now you would put everything in the calculator to get your final answer.
Click, 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 click.
Wait, but don't forget that this is average, so I think you will have to divide by 4.
So why are you dividing by 4?
Well, this was taken within the first 4 hours, and so you would either multiply by 1/4 or divide by 4. You know what? Maybe we should think about when the rate of people in line was at its greatest and at its lowest.
Wait, I think I get it now. Let me try.
In order to find the fewest numbers of times at which the rate of change can equal 0, we can look at hours 1 and 4. And notice that at hour 3, 176 people is greater than both 156 and 126 people. Therefore, at some point between hours 1 and 4, there must be a maximum. Now looking at hours 3 and 7, you can notice that at hour 4, 126 people is less than 176 and 150, which means there could be a minimum at this point where rate of change is also equal to 0. Finally, looking at hours 4 and 8, notice 150 people is again greater than 126 people and 80 people, so there must also be a maximum between these hours. There are at least 3 instances at which the rate of change is equal to 0. I wonder how many tickets were actually sold by 3 p.m. though. The rate at which tickets were sold for 0 is less than or equal to t, which is less than or equal to 9, is modeled by r of t equals 550t e to the negative t divided by 2 power tickets per hour. Based on the model, how many tickets were sold by 3 p.m.? T equals 3 to the nearest whole number.
To find the rate at which tickets were sold by 3 p.m., we use an integral from t equals 0 and t equals 3. Using the given function 500 t, well in this case x, times e raised to the negative x divided by 2 times dx. Therefore, from 0 to 3 hours, 973 tickets were sold by 3 p.m.
Okay, so 973 tickets were sold at 3 p.m.
Wait, but there's only 977 seniors in the senior class. So, who's the missing person? Let's find out.
So you want to go with Matthew, you want to go with Matthew, and I want to go with Matthew? Wait.